What it do, Java crew? Welcome back to another Java video. Oh man, that was super lame. Welcome back to another Java video. In this video, we're going to be talking about Chapter 6, which goes over loops. So in this video, we'll talk about what a loop is, how to write loops, different kinds of loops that are in Java, and then we'll look at some examples along the way. So to get right into it, we'll talk about what a loop is. So the question here says, what if we wanted to do something 100 times? So a loop allows you to do that. So in programming, people use loops to create these sequences to allow programs to run over and over and over again until a certain condition is met. Or if you want to run something a certain number of times, you can use what is called a loop. So in really general terms, a loop is what you use if you want to run something over and over again. So this is kind of the flowchart structure of what a loop looks like. So you're going to start up here. You're going to evaluate some kind of check condition, so it'll be some kind of Boolean expression, and then if that expression evaluates to be true, you follow this flowchart, and then you do whatever's in the loop body, and then it just goes back to the beginning, and then you do the Boolean expression again and again. So this part right here is what actually creates the loop. The loop keeps on going over and over again insofar as the check condition is always going to be true. As soon as that check condition is false, you exit the loop. So in a nutshell, that's kind of how a loop functions, right? You enter the loop by going through some kind of check condition, and if the check condition evaluates to be true, the loop is going to keep on running over and over again, and then as soon as that check condition evaluates to be false, you'll exit the loop. So in Java, you'll notice there are three different kinds of loops that you're going to be working with. So the first loop is what is called a while loop. And a while loop is different from all the other loops in that a while loop has a loop controlling condition at the beginning of the loop body. So you specify some kind of condition to check whether the loop will run over and over again, and then while that condition is true, the loop will keep on running. The second type of loop you're going to be working with is a for loop, and a for loop is used whenever you have the exact number of times that you know you want the loop to run. So right here it says it's a concise format to execute loops. So if you know how many times you want your program to run, you can use a for loop. And the last loop we have here is what is called a do-while loop. So a do-while loop is kind of the reverse of a while loop. So in a do-while loop, your loop controlling condition is going to be the last statement in your loop. So the check condition comes at the very end of the loop in a do-while loop, whereas the check condition is always at the beginning when you're using a while loop. And we'll get into what exactly each one of these loops looks like when we do the different examples. But for now, that's just kind of how to know when to use each individual loop in Java. So this is an example of how to actually write a while loop. So like we said earlier, a while loop is something that will execute a body of statement continually as long as a Boolean expression is true. So to kind of put that into perspective and how that actually looks in Java code, we'll look at the example here. So on the right side here, this is what the code looks like if you actually want to create a while loop. So the first thing you're going to want to do when you're creating a while loop is you're going to want to declare some kind of loop control variable. And that's what they do here, right? So they initialize their LCV. So LCV here just stands for loop control variable. So what that means is that you have to have some kind of way of controlling your loop. And the way you control a loop is through what is called an LCV. You can name it whatever you want. In this case, they decided to stay kind of relevant and actually name it LCV. But you can name your loop control variable whatever you want as long as you know that it's your LCV and it's actually controlling your loop. So if we look at what's actually going on here, so we see that the first thing they do, obviously, is they declare their LCV, and then right after that, they declare some kind of limit. So they want this loop to run like 11 times, no more than 11 times. So, and then they initialize their loop control variable to 1, and then they actually create the while loop body. So in the body here for the while loop, they just say the word while, and then in parentheses after the word while is where you're always going to write your test condition, your Boolean expression, whether it's going to be true or false. And if it's true, the loop body will run. If it's false, it'll do something else. So in this case, the test condition is that as long as the LCV is less than the limit, the loop will run. In other words, while LCV is less than limit, run the loop body. In this case, LCV was initialized to 1, and so 1 is less than 11, and so that condition checks out to be true, and so you'll run the loop body. And so when we actually get into the loop body, we see that the loop here will print out the LCV. And so it'll print out the number 1, and then after it prints out the number 1, it'll add 1 to the LCV, so it's incremented by 1. So now the loop control variable, or LCV in this case, becomes 2 because you added 1 to the LCV, and then you go back to the top of the loop again, and it says while LCV is less than limit. So in this case, LCV isn't 1 anymore, it's 2. So now the test condition is while 2 is less than 11, you run the loop again. And so obviously 2 is less than 11, and then you're going to run the loop one more time. And then that same process happens over and over again. So then, 1 gets added to 2, and then it becomes 3, and then 1 gets added to 3, it becomes 4, and you keep on running the loop until you're no longer meeting the test condition in the parentheses here. As soon as that test condition tests out to be false, then you exit the loop body. And so when that test condition actually checks out to be false is when the LCV reaches the number 11, because obviously 11 is not less than 11, so that will be evaluated as false, and then the loop will stop running. So this loop will run a total of 10 times. So kind of just to put that into perspective and see how it looks on the flow chart here on this side, we'll see that it's exactly what I just explained. So LCV gets initialized to 1, and then it gets passed down to the decision structure here that asks you, is the LCV less than the limit? So in this case, is 1 less than 11? And obviously, that checks out to be true, so you keep going, and then you output the loop control variable, you add 1 to the loop control variable, and then it sends it back here, and loop control variable is now 2, and then it keeps doing that entire process until this test condition checks out to be false, and as soon as it's false, you can exit the loop body. So in really general, broad terms, this is kind of the structure behind writing a while loop. And so now you'll see that there are a couple different kinds of ways that you can describe loops. So a loop can be either definite or infinite. So a definite loop is kind of what you want to aim for. You typically want to write definite loops in your program. So a definite loop is a loop in which the body of the loop has a way that it's being controlled through a loop control variable here. And that's kind of what we talked about, is that you know that you can control the loop because you have a variable inside the loop body that allows you to control the loop, and the loop will eventually end. Like, the loop won't go on forever because you set up some kind of test condition that'll say, okay, once the number reaches, this certain amount, then the test condition will be false and we can exit the loop. So a definite loop is a loop in which you can exit by using means of a control variable. So as long as you can exit the loop, it's a definite loop. And on the flip side of the coin, you have what's called an infinite loop. And an infinite loop is what I talked about, a little bit, that it's a loop that never really ends. So if you don't have a control variable inside your loop, you're probably writing an infinite loop. And infinite loops are usually mistakes. You don't want to write infinite loops. An infinite loop is something that will never end. So if I wrote an infinite loop in my text editor will literally never stop running code until my text editor crashes, because that's just how an infinite loop functions. There's no way to exit an infinite loop, so the text editor is going to keep spitting out output until you either close the program down or you rewrite your code and then rerun it. So you want to avoid running infinite loops, and we'll look at an example of both of those as we move down in this chapter. And so this is an example of a loop that will run an infinite number of times, because this test condition will always be true. And so the test condition here is that while 4 is greater than 2, then I want you to output the word hello. And so obviously me and you know that this test condition here, 4 is greater than 2, is always going to be true. 4 is never going to be less than 2, and 2 is never going to be greater than 4. So that test condition will literally always output the Boolean true. And so as long as that happens, then this loop is never going to end, because if we look at the flow chart here on the left, we see that, you ask the user, is 4 greater than 2? Then the answer is true. And so you're going to follow that structure. You're going to output hello. You're going to go back to the beginning here. You're going to ask the same question over and over and over again, and the answer is always going to be the same every single time. So this is an example of a way to create an infinite loop, and you want to avoid doing this. And so the way you actually go about avoiding creating an infinite loop is by specifying a loop control variable, kind of what we talked about earlier. So a loop control variable is just a counter, or something that allows you to exit the loop, to actually manipulate the loop body by setting up some kind of control variable to it. So in this example here, we have a loop control variable, we call it loop count, and we initialize it to 1. And we say, while loop count is less than 3, then run the loop. And so 1 is less than 3 because we initialize loop count to 1, so 1 is less than 3, and so that checks out to be true, so we'll print out the word hello. And so the most important part here is the part that's highlighted in blue, is that you have to have some kind of way of modifying your loop control variable inside of your loop. So by modifying it, you're telling it that every single time this loop runs, I want you to add 1 to loop count, which is our LCV. So you're going to add 1 to loop count, and so now loop count is equal to 2, and then you go back to the while loop conditional check, and you say is 2 less than 3, and that evaluates to be true, and so you run the loop, and then you add 1 to loop count again. And then now loop count is equal to 3 because you added 1 to it. And so now loop count is equal to 3, you go back to the test condition and you ask it, is 3 less than 3? And that evaluates as false, and that gives you a way to exit the loop. So that's why loop control variables are so important here, is because it gives you a means to exit the loop. So anytime you're able to increment or decrement a certain LCV inside of your loop body, then that gives you a way to exit the loop, and that's critically important because if you don't do that, you'll probably end up creating an infinite loop, and we want to avoid creating infinite loops. And so in this example here, this kind of deals with the scope of loops. So if you remember back to the Chapter 5 video, in the Chapter 5 video, I kind of laid out examples of what exists within the scope of if statements. And so in the same sense that, whatever exists inside of the scope of if statements, and whether you use curly braces or not for if statements, it's the exact same logic that's applied to loops. So with loops, you can either write them with curly braces or without curly braces. But keep in mind that if you don't use curly braces when you write your loops, the loop will only read the first line after the loop. So the only thing that's ever going to loop here, so right here, you have, your loop, the while loop, and so I don't have curly braces in this scenario, and so the only thing that's actually being looped is this line right here, the system.out.print hello line. So hello is going to be looped over and over again, but the second line here, loop count, the actual incrementation of our LCV does not exist within the while loop, because the while loop, if you don't use curly braces, will only ever read the line immediately after it. So even if there's indentation here, then it doesn't matter. So like here it says this indentation has no effect. So even if you indent the code, it's not actually going to read it in the loop, because loops will only ever read the first line immediately after the loop, if there's no curly braces. So I recommend just using curly braces whenever you're writing your if statements or writing your loops. This is how they're going to try to trip you up on the exam. They'll give you an example of something that looks like it's inside of a loop when it's really not. So it's up to you to kind of be able to read that code and understand what's actually inside the loop and what's not inside the loop. And so in this example, just like examples that we looked at in Chapter 5, you don't want to have semicolons at the end of your loop statement. So in this case, they put a semicolon at the end of the declaration of the while loop, and the reason why you want to avoid doing that is because that'll force your loop to have an empty loop body. So even though you think you're writing a loop, if you put a semicolon at the end of the loop statement, then that's going to end the loop right there. A semicolon kind of indicates that you don't want to include anything else after that, so avoid putting semicolons at the end here of your actual loop statement, so don't put semicolons there. And so now we'll just look at a couple examples of what while loops look like. So like we said, up here you have your LCV. In this case, we initialize it to 3, and then you actually have your loop statement here where you say while loop count is greater than 1, then run the loop. And so in this case, 3 is greater than 1, and so the loop is going to run. And so then you have a way of altering your LCV, or your loop control variable, by decrementing it by 1. So in this case, you're subtracting 1 from loop count. And so, after you subtract 1 from 3, it becomes 2, and so 2 is still greater than 1, so the loop will run one more time, and then you get to 1, and then 1 is not greater than 1, and so the loop will cease to run at that point. So hopefully this is making sense to you guys. If not, let's look at another example here. So we'll actually hard code an example of how to actually write a while loop. So let's say I have instructions to where I want to write a while loop that will show me every single increment of 5 100 times. So in really simple terms, I just want to create a program that counts up by 5 each time 100 times. So we'll just go ahead and start with our class here. So I'll call it public class increment, and then obviously in there we have our main method. So we'll go ahead and write our main method here, and then inside of the main method, now you're actually getting into writing the loop and what variables you're going to need to have. So in this case, we want to have some kind of counter for every single number that we're going to count, right? So we'll go ahead and initialize an integer called count. We'll start that value off at 0, and we'll change the value of it later on. And then that was the first thing. And then the second thing is you cannot forget your LCV, your loop control variable. So we want to initialize some kind of LCV. In this case, I'll just go ahead and call it LCV. You can call it whatever you want. And then I'll also initialize that. But in this case, I'll initialize it to 1 because I want to start at 1 and I want to count all the way up to 100. So I'll initialize my LCV, and then keep in mind that you always have to initialize your loop control variable obviously outside of your loop. Don't initialize your loop control variable inside your loop, or else that'll throw your program completely off. And so we have our LCV here. So now we're ready to open up our while loop. So we'll go ahead and write the word while. And so the test condition here is that obviously I want to run something 100 times. So if I want to run it 100 times, I have to mention that in this test condition. So I'll say while this LCV is less than or equal to 100, I want to run this loop. So it's saying every single time I run this loop, the number can never exceed 100. So it's always going to run up until the point that I reach 100, and once I reach 100, it'll stop running. And so inside the loop body, we'll actually write what we want the program to do, right? So like I said, we want it to increment by 5 every single time until it counts 100 times. So there's going to be 100 different numbers that show up on my screen, and I want it to increment itself by 5. So just add 5 every single time a new number pops up. So we're going to be using the variable called count that we already initialized. So we'll say count is equal to, and I want to set count equal to count plus 5. Because every time it sees count, I want it to add 5 to it, and then keep adding 5 to itself. And so obviously I want to display that so we can see the results. So I'll go ahead and write a system.out.print statement here, and then obviously all we're printing out is count. And then it seems like we're done here, but the most important part of a loop is writing the loop control variable and how you're actually altering it so that this doesn't become an infinite loop. So I'll show you an example of what an infinite loop looks like in a second, but let's go ahead and finish this program. So I'm going to increment my LCV by 1. So I'll say LCV is equal to LCV plus 1. So that every single time this loop runs, I want it to add 1 to my control variable and keep adding 1 until I reach the number 100. As soon as I reach the number 100, the test condition will prove to be false and the loop will stop running. So if we go ahead and run this program, we'll see that we get the results as desired, right? So we have 100 different numbers here, and they're all being incremented by 5. So if we scroll up to the top, it goes 5, 10, 15, 20, 25. So it keeps getting added by 5, and there's 100 different numbers here. So it does this 100 times until it reaches the very end of the loop. And so, I can do whatever I want here. I can increment it by 10. I just change the number 5 to 10 and rerun the code, and it'll do the exact same thing, but for the number 10. So that's an example of a definite loop using a while loop. So let's look at an example of what an infinite loop looks like. So the way you create an infinite loop is just you don't, control the variable inside your loop body. So if I just got rid of this line of code here, this loop will never exit. So hopefully this doesn't crash my text editor or anything, but let me go ahead and run this. So as I'm running it, you can see these numbers are just going to keep building on themselves. It's literally not stopping. It's just going to keep creating new numbers. And I don't want my text editor to crash, so I'll go ahead and I'll cancel out of it just by hitting escape. But if I don't hit escape, this number, will never stop, creating new numbers. I can literally fall asleep, wake up the next morning. It'll still keep adding 10 or keep adding 5 to whatever I told it to do. So as you can see, this thing is literally not stopping. It's just adding more tens to the number over and over again. So I'll go ahead and escape out of this. And so you can kind of see what an infinite loop looks like, and you don't want to create infinite loops because there's no ways to control them. So obviously, always make sure you have your loop control variable inside the loop body so that you have ways of controlling that variable. So now that we've kind of seen what definite loops look like, and then I've shown you guys an example of what infinite loops look like, there's something called an indefinite loop. So an indefinite loop is different from a definite loop and is different from an infinite loop. It's kind of a combination of the two. So the way we define what an indefinite loop is that it's a loop that's controlled by the user, but it'll run an indefinite amount of time. So we don't know how many times the loop is going to run, and the amount of times the loop runs is totally up to the user. And so what this loop actually does is that it kind of keeps looping the program over and over again until a user enters some kind of data that'll validate the program, right? So as soon as a user enters something that the program wants to see, the loop will stop running. So right here it says if a user enters incorrect data, the loop will keep repeating. So if the user does not enter correct data, it becomes an infinite loop. But the user can stop the loop if and only if they enter the right data. So let's look at a quick example. So the best example I could come up with is, let's say you're an individual who's browsing a website that you probably shouldn't be browsing, like a naughty website. I'll leave it at that. So a lot of times these websites want to validate a user's age, right? Like if you're over 18, it'll let you into one of these websites. But let's say someone who's not over 18 is trying to get into these websites, and if they input their age is less than 18, then we can create an indefinite loop and keep asking them to keep entering their age. We'll display a little message that says, hey, you're not old enough. Keep entering your age until you tell me that you're over 18. And once you tell me that you're over 18, then I'll let you into this, like this naughty site or whatever. So this is the best example I could come up with. So let's go ahead and code what that would look like if we want to create an indefinite loop for a website to validate a user's age. So obviously, the first thing here is that we're going to be asking the user a question. So I'll just go ahead and import JOptionPane up here. So javax.swing.jOptionPane, and then we'll say public class, and I'll call it naughty site. And then in our class, we'll have our main method. So we'll go ahead and write our main method up here, and then in the main method, we have to figure out what variables we're going to be using. And in this case, the only variable that we have is the variable of age, right? So we want to ask the user what their age is over and over again until, it gives us we validate that data. So we'll go ahead and declare a variable, call it int age, and then we'll also go ahead and, parse everything and do it all in one line of code here. So we'll say integer.parseInt, and then in the parentheses, we'll actually ask the user to enter their age. So we'll say JOptionPane dot show input dialog, and then we'll open our parentheses. We'll say null, and then we'll say enter your age. So let's say the user enters their age. Now we want to create some kind of loop that'll keep prompting the user to enter their age so that we can verify that their age is over 18. So we'll go ahead and write a while loop for that. So we'll say while age is less than 18, so this is kind of like an error message that will pop up every single time age is not greater than 18. So anytime someone who's younger than 18 enters their age as like 13 or 14, they'll get this error message that'll prompt them to re-enter their age. So anytime a user who is not 18 enters their age and it's less than 18, we'll say go ahead and re-ask the user a question and reassign the value of age. So we'll say age is equal to, same thing here, integer.parseInt, and then exact same syntax. We'll just ask the user to ask another question. We'll say you are too young. Please please re-enter your age. So it gives the user a little message. It says, hey, you're too young for this website. You're not 18. Keep on re-entering your age until I can validate that you're actually 18. So this part right here, lines 7 through 10, is what kind of creates the loop, that little error message that tells the user that you are not 18, and insofar as you enter an age that's not above 18, I'm going to keep asking you over and over and over again your age until I get an age that's valid. So this is what I kind of mean by, an indefinite loop. This loop can run one time or it can run 100 times. Someone who's 13 can keep inputting their age as 13, and each time they input their age as 13, the loop is never going to exit. It's going to keep running the same loop over and over again because obviously 13 is less than 18, so that test condition is always going to be true. But let's say someone who's 19 comes along and runs this program is only going to execute once because as soon as they enter 19, the data will be valid. And so that's why we call it an indefinite loop, because it's indefinite how many times this program is actually going to run. So let's say they pass that check, right? Let's say they actually are above the age of 18. So we just want to have a little display message here that says, welcome to our site, or something like that. So we'll do a show message box for that. We'll say, congrats, right? Because it's an achievement. Congrats, you are over 18. And we'll say, welcome to the site. Have fun. And we'll put a little winky face at the end. Okay, so now we've created this program, and so what this program does is it asks the user for their age, it takes their age. If their age is not above 18, if they're younger than 18, then I'm going to keep on asking them for their age over and over again until the user enters an age that is above 18. As soon as they enter an age that's above 18, we'll show the message that says, congrats, you're over 18, welcome to the site, have fun. So it looks like we're done, so let's go ahead and run this program, see what happens. So it says, enter your age. So first question pops up, enter your age. Let me go ahead and enter 12. So I enter 12, and then it gives me a message that says, you are too young, please re-enter your age. I'll enter 12 again. Same message, I can enter 14. Same message, I can enter 15, same message. I'll enter 16, same message. So I can enter numbers over and over again. It'll literally keep bringing up the same dialog box every single time. But as soon as I enter an age that's above 18, so let's say there's a creepy old man trying to get on this site, and so he puts in like 65. So this guy is 65 years old. So I press OK, and so that validates that 65 is indeed greater than 18, and so we'll send a message that says, congrats, you are over 18, welcome to the site, have fun. And so that's kind of how the program works. So it's an indefinite loop in that we don't know how many times it's going to run. It's going to run over and over again until we validate the data that's being given. So hopefully this makes sense to you guys. Maybe try to create your own little program that kind of uses indefinite loops. So hopefully that makes sense. And so kind of moving on, one thing to note with Java is that Java provides you with a lot of shortcuts that you can use, especially when you're using like arithmetic and stuff like that. So when you're writing loops, you're going to be doing a lot of like incrementing and decrementing and stuff like that, because obviously you want to control your loop control variable. So Java has shortcuts anytime you want to add by one or subtract by one or something like that. So right here, there's shortcuts for incrementing. So if you want to add and reassign something, then you can just use the plus equal sign. If you want to subtract and reassign, you can use minus equal sign. So that's kind of a shortcut to show you what it looks like. Look at the example down here. So if you're trying to reassign age, so this is exactly like the example I was just doing. I was using age, or if you're doing like an incrementer, you're like a loop counter or something, you're going to want to add one to your loop counter. In this case, we have age, and then we set age equal to age plus 1. So each time someone enters their age is going to be added by 1. But that line of code right here is the exact same thing as a line of code right under it. So that's kind of how to use a shortcut. So age is equal to age plus 1. A quicker way of writing it is just doing age plus equal 1. They both mean the exact same thing. One way is just kind of a simpler way to do it. And it's a little bit quicker, so just be familiar with both ways. The second way would probably, like show up on your exam or something, or even, maybe you like doing it the quicker way. So just keep in mind that there are shortcuts to do these operators, and I'll show you, different examples, and we'll look at an example of how to use these operators. And so another thing to keep mind of is incrementing arithmetic operator. So a lot of times, like I said, you want to add 1 to certain things, or you want to minus 1 from certain things, especially when you're working with loops. And so one way of doing it is using a prefix or a postfix increment or decrement operator. And so what that looks like is just by having a plus plus at the beginning or the end of a certain variable. So in this case, you have plus plus some value and some value plus plus. So there's just different ways you can add 1, or you can just use it with the minus sign here. You can put 2 minus signs at the beginning of a variable or the end of a variable. So just one thing to keep in mind is that this only works with variables, and it'll increase or decrease a variable's value only by 1. So just to look at an example and kind of put it into perspective. So it's the same program that we created in the beginning. It's the program that's counting by 10 or counting by 5, but let's see if we can make this program a little bit more efficient. So in this case, we have the line of code here on line 9 that's adding something to count and reassigning it back to count. So a quicker way of doing that is that we just get rid of this here and just say plus equal 10. So if we do plus equal 10, it's the same thing as saying count is equal to count plus 10. So this line of code is the same thing as this line of code, but this way just a little bit quicker. So plus equals 10. So these are just efficiencies, little efficiency things that you can be doing in your program. And then down here, we're incrementing our loop control variable by 1. Instead of writing out the entire line of code, I can just do LCV plus plus, or I can do it as a prefix and do plus plus LCV. Either way, it'll still increment it by 1. And we'll talk about the difference between prefixes and postfixes in just a bit, but just know that either way you do it, it'll add 1 to the loop control variable. So let's go ahead and run this, and we'll see that the desired output is exactly the same as it was before. Nothing really changes. There's just different ways of writing this code. You'll be seeing the plus plus a lot in this class, especially when you're writing like for loops and stuff like that. And so now that we've seen examples of what that looks like in code that we've already written, we'll talk about the difference between postfix and prefix. So, sometimes the plus plus comes in the beginning, sometimes it comes in the end. But, to me and you, it's just adding 1 every single time. So we have to see what the difference is between that. So this last line here says prefix is slightly faster than postfix. So we'll look at what that means exactly in this example here. So in this example here, you're doing increments using postfixes and then prefixes. And so when it says that a prefix is faster than a postfix, this is what it's talking about. So let's say we have a variable called test. We initialize it to 0 up here, and then in the line of code right after it, we want to print out test. So we want to print out test, but we want to add 1 to test. So right now test is equal to 0, but we want to add 1 to test. So if we do test plus plus, and we wanted to display something, to me and you, it would display 1, right? Because we incremented it by 1. But to Java, it's actually going to display 0. And the reason why it does that, this is probably the most frustrating thing to deal with in Java, but you have to be able to recognize this because they're going to try to trip you up with this on the exam. So using this incrementer as a postfix, I kind of laid it out down here. I made a little note. So postfix, whenever you have a variable and then you have a plus plus after it, the value of the variable is changed after you display it. So although we did add 1 right here, so we do a plus plus, and a plus plus is adding 1. So we did add 1 to the value of test. So the value of test is actually 1, but the value of test doesn't become 1 until after it's displayed. So whenever you display it, it's going to display 0. But just know that the value of it is actually 1. And so we'll see that, in the second line of code here. So in the second line of code, we're doing the exact same thing. We're doing a print statement, but here we're doing a prefix increment into the value of test. So prefix, in the slide above said that prefix is a little bit faster than postfix in that prefix, look at the note down here, prefix, the value gets changed before it displays. So as me and you know, the value of test is already 1 because we incremented it by 1 in the first line of code. In the second line of code, the value of test becomes 2 because we added another 1 to it. So when you actually display it, the value is going to be 2. And so the reason why we know it's 2 is because it got added by 1 in this first line here, and they got added by 1 in this second line here. So it went from 1 to 2, and then when you actually display it, it's going to display 2 here because prefixes values are changed before the display. So when you actually display them, it displays the full value amount. Whereas postfixes, the value isn't changed until after they get displayed. So it's the exact same thing with this final line of code here. So this final line of code, you're decrementing or you're subtracting 1 from test. So obviously when you subtract 1 from 2, it should go back to 1. But when you actually display it, it's still displaying 2 here because it's a postfix, so it comes after the variable. And when it comes after the variable, the value doesn't change until after it's displayed. So it's still going to display 2, but the value is actually going to be 1. So the final value of test is that test is equal to 1. After running all those 3 lines of code, the final value is that test is equal to 1. But when you display the final print statement, it's going to display 2. So I know that's extremely confusing, but this is something that you guys have to understand for the exam because there's definitely going to be a question over this on the exam. So I would definitely try to understand what's going on here. Maybe pause the video and try to understand that postfixes, the value gets changed after displays, and then prefixes, the value gets changed before displays. So now that we've looked at while loops, we can talk about for loops. So we kind of understand what while loops are. We know how to set them up. We know how to manipulate them using loop control variables. So a for loop is used whenever you know the amount of times that you want the loop to run. And let's say you know how many times or how many iterations of the loop you want to run. And so that's when you would actually use a for loop, because a for loop is more exact in its number of iterations. And for loops, people think are kind of more convenient. I actually prefer writing for loops as opposed to like while loops or do while loops because they are more convenient. So for loops are one convenient statement that indicates the starting value of the LCV, it indicates the test condition, and it has the expression that alters the loop control variable. So all those things that you had to do in the while loop, initializing a loop control variable at the very beginning, and then having a test condition inside your while parentheses, and then altering the loop control variable and having that expression exist inside the loop body. All of that is done inside of the parentheses of the for loop. So it's a lot more convenient, a lot more efficient in terms of writing loops. So if we look at the example down here, this example is 2 loops that are doing the exact same thing. So let me go ahead and highlight them. So in yellow here is the for loop. Oops. So that's the for loop, and then I'll go ahead and in green highlight the while loop. So the while loop and this for loop are both doing the exact same thing. They're both just printing out a certain value and then incrementing it by 1, until that loop runs 10 times. But the for loop is less lines of code because you're indicating everything in the parentheses here for the for loop. So inside the parentheses of the for loop, it's set up, kind of similar to a while loop. You have the word for, and then you open your parentheses, and then in the parentheses, you initialize your LCV, so your loop control variable, you set it equal to 1, and then you can do your test condition, specify, how long you want the loop to run for, and then you can increment it at the very end. And these are all separated by semicolons. So there's 2 semicolons that exist inside for loops, and then based on that, it'll just print it out. And if you look at the while loop down here, it does the exact same thing, but in my opinion, it's kind of just more work because you're doing all the conditional checks and stuff like that. You're doing them on separate lines of code, whereas in the for loop, you can do everything in one line of code. So let's look at an example of what a for loop actually looks like. So in this example here, it's a pretty simple, straightforward for loop. So if you guys don't know what knots are, so knots are like nautical miles, kind of like how fast like a boat travels or something. So they're just like a unit of measurement. So in this program, I want to convert knots into kilometers and into miles. And so I want to do that for 10 knots. So like 1 knot, 2 knot, 3 knot, all the way to 10. So I want to know the conversion from 1 to 10 knots into kilometers and miles. And so I set up a loop here. I set up my loop control variable, so I initialized it here. So I said int knots is equal to 1. So you can do all that in one line of code. I have my semicolon, and right after that I have my test condition. So I say as long as knots are less than or equal to 10, then I want this loop to run. So I want this loop to run 10 times, and then every single time this loop runs, I want you to increment 1 to knots. So I want to know how much 1 knot is, and then run that 1 time, and then increment up to 2, I want to know how much 2 knots is, and then 3, and then 4. So each time this loop runs, it's going to get incremented by 1. And then obviously every time this loop runs, I want you to print out this statement that says, 1 knot or 2 knot is equal to, then I have the conversion here to kilometers, and then I have the conversion here into miles. So it'll just display how many kilometers or miles each knot actually is. So if I go ahead and run the code, you'll see that I get the desired output here. So it says 1 knot is equal to however many kilometers and miles. And then, that loop ran once, and then it gets incremented by 1, and then it goes to 2, and it says 2 knots is equal to this, and then 3, and then 4, all the way up to 10. So that's just an example of kind of how a for loop, functions and what it looks like. So for loops, in my opinion, are a lot more simpler, but you just have to know what to include in the parentheses here, in these test conditions. So that part is the most important part of a for loop. And so these are just some extra notes to kind of just know about for loops. So there's more stuff that you can do inside the parentheses of the for loop. You can initialize more than one variable inside of the for loop. So just kind of to show you what it looks like. If I had knots here equal to 1, I could also do like int miles is equal to 1 or something. So you can initialize multiple variables there. So that's one thing to note. And then it says that the performance test or the conditional test can use logical and or operators. So like we talked about in the last chapter, and or operators are just test conditions to evaluate whether something's true or not. But you can also include them in for loops. So if knots is less than 10, or if like knots, or let's say, or miles is greater than 10. I don't know, I'm just making this up, but just to show you an example that you can have another operator there, like an and or in order to have multiple test conditions. So that's one thing that's cool about a for loop, is that you can include and or operators in them. And then the final thing to note is that you can leave one or more portion of the for loop empty, but you always have to have 2 semicolons. So if you don't want to have like a loop control variable or something, let's say you don't want to have a test condition, or you don't want to increment the knots or something. So let's say I don't want to increment knots. Let's say I want to increment knots in the actual loop body. So I want to do knots plus plus, and I want to have it there instead of having it up here. I can get rid of it up here, but I still need to have the semicolon here. So if you want to get rid of a certain section of the for loop's always going to have 3 sections. If you want to get rid of one of the sections, you still have to have the semicolon. So always keep that in mind. Or let's say you want to get rid of the first section here. You don't want to initialize some kind of control variable. You still have to have the semicolon. So even though it kind of looks weird to have the semicolon at the beginning of the parentheses, just know that you always have to have at least 2 semicolons in the for loop. There's always going to be 2. So there's just different things that you can do with for loops. And so now that we've talked about for loops, we finally get to do while loops. So do while loops are really similar to while loops, but they run kind of backwards. So it's called a post-test loop. So the test condition, or the check, always comes after the loop runs. So you do something while that this test condition is evaluated to be true. So kind of how that looks in the flow chart is that you have your loop body up here. So you're gonna start up here. You're gonna run the loop body. So one thing to know about do while loops, they're always gonna run at least one time. They're always gonna run once because of the do part of it. So the do is always going to allow the loop body to run once, and then the test comes after the loop runs at least one time. So if we just follow the flow chart here, so you start at the top, you go to your loop body, the loop runs one time, and you go down, and then you evaluate the test condition, and then, obviously if it's true, you're going to go back and run the loop over and over again, and if it's false, you're just going to exit the loop. So that's kind of how do-while loops are just kind of different from while loops. Like it says here, it says the test control variable is going to be at the bottom of the loop, and it's going to run after one repetition, and then a do-while loop will perform a task at least one time. So let's kind of look at an example of a do-while loop. So we're going to use the same example that we used for the while loop, right? So in this while loop example, we're just going to change it and kind of flip it around. So let's get rid of this while statement here, and let's change it to a do statement. So let's say do. So it'll do all these tasks that I specified inside the loop body while that condition is checked out to be true. So all I did here is that I put the conditional test at the end, and I wrote the do statement where the while statement used to be. So this loop body is always going to run at least one time. So it's going to do everything in that loop body while this test condition is true. And so in this case, it doesn't matter which way you write it, but obviously, do-while loops do serve their purpose. So there's some cases where you have to use a do-while loop instead of a while loop, but this is just kind of to show you what a do-while loop actually looks like. And so this is kind of how to set it up. You have the word do, you have your loop body, and then you have the word while, and make sure the word while is also in the same line as the do statement, so they have to be like lined up vertically. And so you have your while keyword here, and then you have the test condition inside of the parentheses of the while statement, and at the end you have a semicolon. And so if we go ahead and run it, we'll see that it does the exact same thing, still incrementing by 10, but in this case we're just using a do-while loop to execute that function. And so the last thing that we're going to talk about here is what are called nested loops. So we've heard of nested if statements. We talked about that in the last chapter. So nested if statements are just when you have if statements within if statements. So in the same kind of, line of thinking, you can also have nested loops. But whenever you nest loops, you call them inner and outer loops. So, one loop exists within another loop. So we'll kind of show you an example here at the bottom. So in this example, let's say, you're working at some kind of like printing company or something like that, and then you have orders for certain labels that you want to print out. But you want to print out 3 different colors of mailing labels for 20 different customers. So you have 20 different customers, but each customer needs to get a different color label printed out for them. So you can write a loop within a loop. So the first here, this outer loop here, so this first loop is called the outer loop, is for the customer. So you want to loop through each customer. So for the first customer, I want to print out 3 labels. For the second customer, I want to print out a certain number of labels. So you're looping through every single customer 20 times because you have 20 customers. And so the second loop here is called the inner loop, is looping through the number of labels. So for the first customer, so you're starting at 1 because you initialize customer to 1. And so for customer 1, he's getting 3 different labels. So every time the first loop runs, the second loop is going to run 3 times. So hopefully you guys can see how that's working. And so the second time, customer gets incremented by 1, so you go to customer 2. And so customer 2, that inner loop is going to run 3 times for customer 2 because you want to print out 3 different labels. So every single time the inner loop runs for the color labels, it's going to run this line of code here that says output label. It's going to run some kind of method that's going to actually print out the labels that we need it to print out. So for every single customer, that customer is going to get 3 different colors of labels. And each time the inner loop runs, so it's going to run 3 times, it's going to print out a different color label. So it's going to print out 3 different colored labels for each customer, and there are 20 different customers. So if I asked you the question, how many times is this entire program actually going to run? Like how many labels are going to be printed out at the end of the day, right? The answer to that question is that there's going to be 60, because the outer loop is going to run 20 times, And then for each time the outer loop runs, the inner loop is going to run 3 times. So that means that this loop is going to run a total of 60 times. And one way of kind of just indicating how many times a certain nested loop is going to run is that you can just make an indication that, okay, this is going to run 20 times, this is going to run 3 times, and if you just multiply them by each other, you'll see that it'll run a total of 60 times. So that's how many times this loop is going to run. And, that's just going to cover all the conceptual stuff for this chapter. Hopefully you guys enjoyed this video on loops. Maybe I know loops are a really, difficult concept to understand and to wrap your head around, but it helps if you do a lot of practice and just kind of read a lot of code and really try to understand what's going on with loops, because it does take a while to get used to kind of the methodology and that logical, that line of thinking to understand how loops are actually functioning. But once you understand them, they're really not that bad. They're actually really fun to work with. So that's why I said, like this part of Java is actually really cool, because you can make the computer, do some kind of decisional check, or like make it think like a human, or make it do things over and over again. And then if it does this one thing, then it'll do something else, So it's just super cool things, really cool programs you can start creating. So just start playing around with it yourself. And hopefully this will help you learn loops and if statements. So thanks for watching, guys. Hopefully you guys enjoyed this video. I'll see you in the next one. Peace.